Okay, we'll go ahead and get started with the introductions for this webinar. Welcome, everyone. Today's webinar is going to be on the topic of managing moving slopes. It is a special webinar for us today because we have a keynote speaker, and then we will follow that presentation with a panel discussion based on the topic of that main talk. It is going to be running for 1 hour today. And it is an interactive webinar, so there will be opportunity for you to interact with our speakers and our panel today and ask questions live to them. So this webinar is brought to you by the Geotechnical Center of Excellence. We are an industry-funded and member-led center that is committed to bridging gaps within and between academia, industry, and fields of study through a pragmatic and collaborative approach to both geotechnical research and education. If you're interested in learning more about the GCE, you can go to our website, which is mining.arizona.edu/GCE. As I mentioned, we are industry supported. We are built upon a membership structure, and these are all of our wonderful members that we need to make sure we acknowledge, because without their support, none of our work would be possible. So thank you very much to all of our members with the GCE, as well as our senior advisors and our associate members. We really appreciate you, and together we're able to make great things happen in the realm of geotechnical research and education. So thank you very much. And if you're interested in becoming a GCE member, please reach out. To introduce the webinar team from the GCE, I am your moderator today. My name is Jillian Noonan. I'm a senior R&D engineer with the GCE. And along with me is Cheryl Bukowski, who is our professional development program lead. Thank you for being here, Cheryl.
Thanks, Jillian, and welcome everyone. We're glad you're here.
And also Lara Summers, who is new to the GCE, and Lara is our new program coordinator. Welcome, Lara.
Thank you. Great to be here.
Our keynote presenter today, who will be delivering our main talk, is Greg Abrams. And Greg is a principal engineering geologist with BGC. He has 21 plus years of international consulting and operational experience. And Greg has managed a lot of slope instabilities and is currently providing guidance to many mine sites on how to safely manage and operate with deforming pit walls. So Greg's a wonderful expert to have today. We're really glad you're here. Thank you so much for giving us your time and for providing this talk for us.
Yeah, thanks, Jill. Hi, everyone.
And as I mentioned, following Greg's talk, we'll be having a panel discussion. We also have a wonderful panel of experts here today. We have Andrew Bidwell, who's with Elk Valley Resources. Andrew is the Manager of Geological Engineering. Thank you so much for being here today, Andrew.
Thank you. Good afternoon.
And also Scott Cylwik. Scott is Vice President with Call and Nicholas. Scott, so good to see you. Thank you for being here.
Thanks, Jill. Happy to be here.
And Karyn Gallant, who is with Equilibrium Mining. And Karyn is the Global Operations Lead with Equilibrium. We're very glad you're here today, Karyn. Thanks so much.
Yeah, I'm glad to be here too, and thanks everyone for joining.
And we also have Pat Jenks on our panel today, who's with Nevada Gold Mines. And Pat is the Manager of Geotechnical Engineering with Nevada Gold Mines. Good to see you, Pat. Thank you so much for joining us.
Hi, Jill. Thank you. Welcome, everyone. It's good to be here.
And now for the participants, I'll just run through a little bit of information on how you can interact with us today. So this is a webinar, which means you are automatically muted. Your video is off, so no worries about looking for those controls. If you do have a question today based on Greg's talk or during the panel discussion on those topics that are being discussed, you are welcome to enter those into the Q&A, which is a function you can find on your Zoom control panel. So you just click on Q&A and it will open up a window where you can type in a question. If it's in regards to a specific person or topic, please make sure to note that so that we can direct the questions properly. You can enter them anonymously by selecting a checkbox, And you can also see the other questions that are being submitted and vote for ones that you like and would like to see answered by giving them a thumbs up. We are recording the webinar and it will be posted to the GCE course site and YouTube page following this. And just a quick disclaimer that any views or opinions expressed today do not reflect those of the GCE or any affiliated organizations necessarily, and that the webinar content that we're providing to you is for educational purposes only. If you do need site-specific professional advice or analysis, we do encourage you to seek that additionally. We hope you enjoy the content today in the webinar, and thank you very much for joining us. All right, so with that, I am now very pleased to hand this over to Greg to deliver his talk on observational mining and managing moving pit walls. Thank you so much, Greg.
Great, thanks, Jill. Yeah, hi everyone. So this talk came about following a guidance note that got written between BGC and the LOP, with a huge amount of help from vendors and industry partners and consultants and so on about the observational mining process and how to manage moving pit walls. And we wrote it because we're seeing that trend in the industry. We're seeing more and more places move to a performance-based design. We're seeing a lot of operations try and operate below moving walls. And we thought a guidance note would be a nice way to try and develop a process flow for how this should be done. So it's not an SOP, it's not an operating procedure, and it's a first pass. And it would be really nice to get feedback on it and maybe have somebody update it in a few years. And so it's a living document.
And I forgot to mention, I'm going to ask one of the GCE team to please post a link for our participants where they can go and to the LOP website and download this guidance document that Greg's going to talk about today. It is a free download and yes, provided by the LOP. So if someone could put that in the chat, Laura or Cheryl.
Great. All right, so observational mining, simple terms, what is it? Well, it's a risk-based design operating approach or method where your pit wall geometry and your slope performance and your controls are adapted in response to changes in the ground behavior. And you're going to do that rather than relying purely on a fixed design or a fixed factor of safety that you might have at a PFS or an FS level. And I think a lot of places are probably doing that either directly or indirectly at the moment. But it is not a substitute for sound, defensible geotechnical design. We're not saying you can just go and dig a hole and use the observational method to manage your controls. That's not what we're saying. Okay, next slide. So this is the process flow on the right that we developed. I'm not going to have time to talk through all of it in detail. Obviously, that's all in the paper, but we'll talk on a few of these things. And really, you can use the observational mining approach to identify a potential instability and do that with enough time to implement a management strategy and with enough time to evaluate what your options are going to be, and then indeed progress mining if that's the preferred option for the business when you've evaluated all these things and you've evaluated your mitigation controls and your operational controls and you've looked at your risk and you understand your risk. Okay, next one. Why do we have these instabilities? Well, it is possible that you are in a good buy cut or your economics are, well, they're always going to be challenging, but you're going to use an aggressive slope design and perhaps you're good enough that you're anticipating an instability at the design level. That does happen, but I think most commonly you have the slope move was just unexpected. And don't pick up the phone and blame the consultant straight away. The geology is complicated. The bottom left picture is an example as a published example from Gibraltar, and a lot of faults in that instability. And there's no way you could be expected to identify all those at FS level, design level. The graph on the right, I modified that a little bit from work done by Trevor Carter. Quite a nice little graph On the x-axis is sort of effort of geotech or level of geotech information. So as you move from left to right, you drive that risk down. The blue line comes down. So this is sort of risk of unforeseen problem, to the point where, as you're collecting more and more data, the green line goes up so that the cost goes up, and you'll end up with some sort of optimum expenditure. But look on the far right, and regardless of what you do, you will always have uncertainty, and that's life. Okay, next one. So the first part of this process flow is early detection. So that's seeing the deformation of any potentially moving area with sufficient time to do something about it. So to develop and act on a remediation plan before you're in that unrecoverable trend. Okay, so we're not talking about onset of acceleration here. We're talking about that initial deformation, that sort of onset of yield. And how you're going to do that? Well, it's INSAR data, it's GPS data, it's PRISM data, subsample radar, it's precision atmospherics if you're using ground probe radars. And you're doing it and you're looking at long-term trends. We're talking weeks to months. That's what you're plotting data over, and you're looking for that little onset of deformation. And subsurface, if you're, I don't want to say lucky enough to have it, maybe you're good enough to predict where the high-risk areas are, but subsurface, very, very valuable because you'll always get more deformation in the subsurface. Okay, next slide. And then once you see your moving area, well, you're gonna monitor it with some targeted monitoring. Again, subsurface, I've been criticized for this over the years in the operational space where we've had a lot of surface monitoring, but we've had no subsurface. This is a nice graph that the team at Kennecott put together. I think Forrest Schumacher led this, where we looked at the same slope movement and look at the SAA. You're always going to get a greater magnitude of deformation with subsurface because that's where the movement starts. And then you'll have your GPSs and your prisms because that's true 3D. Extensometer, you might get lucky, and then it's going to be radar. Okay. Even if your radar has an excellent line of sight, you're always going to get a greater magnitude in your SAA and in your prisms and GPSs. So keep that in mind when you develop tarps and you put triggers in there and you say, okay, if my trigger is a certain velocity, what instrument are you actually referring to? VWPs, don't forget VWPs, it's going to tell you a lot. Sorry, Joel. And then redundancy. You're going to want redundancy if you're going to keep mining below a moving wall. You can't just have one radar. It's probably not going to be enough because it's going to break or it'll run out of gas or something's going to happen to it. Okay, next one. Next stage, you really want to bring all the information that you have from your monitoring together to understand that stability mechanism. Okay. Take the radar data, make sure it's georeferenced, whether it's INSAR data, ground-based radar, drape it over the drone flight, drape it over your structural model, over your geotech model. There's probably going to be faults that you don't know about. That's okay. The monitoring data is so valuable for that. Look at your PRISM data and your GPS data. Try and get some vectors out of it. That's what the image on the left is showing. You can see how the arrows are pointing down the way, but we're bulging at the toe. That's going to tell us something. Subsurface. What faults is it shearing on? Which faults is it not shearing on? Okay, this is such an important piece because it's going to lead into understanding the mechanism which you're going to use to build your tarp. How much volume could potentially fail? That's going to feed into the runout analysis and the isolation plan. So yeah, super valuable and a huge piece to this. And you might do some numerical modeling. That's fine. But understanding that conceptual failure mode, super important. Okay, next one. And then start thinking about the economic consequences of a potential collapse. What infrastructure do you have below your moving wall? Have you got in-pit crushers? What's going on at the crest? Have you got infrastructure at the crest that's potentially at risk? Something we're seeing a lot of right now is portals, obviously, we're transitioning to a lot of open pits, transitioning to underground. So you've got portals at the bottom that are potentially a risk, and you're often, we're using there's a lot of in and out going on at the portals because we're trying to pull ore out. So what does a collapse look like from an economic standpoint? Next one. Okay, so we've started to look at our mechanism now. What can we do about it? Well, we've got mitigative controls and we've got operational controls, and we might do a combination of the two. What are our mitigative controls? Nothing new here. You can unload it. You could try a step in. You could step in and buttress it. You might want to mine out the instability. You can do that maybe if it's quite small, and then fill it back in with better quality material. In some cases, if push comes to shove, you might add ground support. But regardless, these things are costly and take time. Certainly, if you're gonna step in, that's either or deferral or loss. Building a buttress, do keep in mind it can be very effective, but then if you're carrying on below it, suddenly that buttress is a driving load, just as much as it is a resisting load above. So it's important to consider how effective these mitigative controls could be. And in the guidance note, we provide a bit of a cost risk approach of how you might want to do that. And if we go to the next slide and look at the operational controls, again, nothing new here, but operationally, what do we want to try and do? Well, we want to keep mining with minimal slope displacement. We want to reduce the chance that your slope's going to progress towards a collapse. So we can depressurize, there's blasting controls you can do, limit the vibration and so on. Free digging can be an option if you have weak rock mass. You can drill the pattern out first and then try and dig it out. Reduce your dig rates, keep that velocity manageable. And that's what this graph is showing here. So we've got the gray bars are tons. This is some nice work done by Megan Guider and team. So that the gray bars are tons, and you can see initially of digging with pretty rapid rates, and the slope velocity is quite high. Have a mining pause, and it comes back down, and then you can keep mining, but at a slower rate, and you can keep your slope velocity manageable. So various things you can do there, but again, there'll be implications to the mine plan, and it's cost and time. Just a quick note, if we're going to try and manage a slope operationally, and why do we keep saying keep the deformation rate manageable? Well, mining a slope that's moving really fast, probably even if it's linear, that bumps up your safety risk, because if it does progress to a collapse, you've got much less time to do anything about it. Now, I agree that I do think by having a slope move, you're not allowing it to build up stress so it can then potentially collapse in a catastrophic manner. I do think in some cases, depending on the mechanism, having a slope continually move can be a good thing, but you've got to keep the rates manageable. If it's moving at 10 inches a day, that is not going to give you much time if it were to progress to a collapse. And that's what I'm trying to show. The graph on the bottom right there, that's an inverse velocity plot for a fast moving slope. If that was to suddenly go progressive, the time between where that line is and the zero there's not much time there. And obviously keep in mind if you are getting into inverse velocity trends, they're not always linear. Okay, the time of failure can be a lot sooner than your predicted time of failure. Okay, and now just on to the safety risk a little bit. I think we need to acknowledge that if you're going to start mining below or even above an instability, it carries more risk. It carries more safety risk than standard operating procedures, if you like, at a mine. So we need to start thinking about that. And I quite like the term tarp efficacy. It's not just how effective is your tarp. Think of it as, what's the likelihood that the pit floor is evacuated prior to a collapse? And there's loads of things that feed into TARP efficacy. It's not just about effective triggers, that's part of it, but it's all about your monitoring equipment. How much of it do you have? How effective is it? Redundancy, we've spoken about that. Capability of the operation. How often are we doing the fire drill? How often are we getting people out? Does the operation listen to the geotech team, or they just completely ignore them and do their own thing? Some operations are well versed at evacuation. Exposure of mine personnel. You might be able to limit the exposure by having just one shovel and one truck in and one truck out. Or if it's a moving area that threatens your only haul road, then you will have that exposure of mine personnel goes up. Failure mechanism, again, very important. How far is it going to go? And then a big one, the capacity and capability of your geotech team. Okay, do you have a monitoring center? Is it 24/7? Is it on site? How good is your team? If we got redundancy in that geotech team, if someone's off on sick leave or paternity leave or whatever, do we have the skill sets in there? So lots to think about, and that's what I want everyone to think about as they build tarps and think about mining below that, moving walls, and are they managing their safety risks? Next slide. Look, a quick note on tarp triggers. I get a lot of calls about this. What should we use? So we did spend a bit of time trying to come up with some suggested numbers, and this is in the document, for what the triggers might be for different tarp levels. We've got velocities, we've got velocity ratios, so you can have a read of that. But regardless, the tarp does need to be instability specific. You'll probably have 3, 4, maybe 5 tarp levels. Make your triggers defensible, build them on as much existing data as you have. The chances are that tarps 1 and 2, for a large moving area, tarps 1 and 2 will be more economic in the sense that it's that slow rates that you're looking for. And you might be in tarps 1 and 2 for a long time. And that's fine. And the chances are that tarps 3 and 4, that's the safety piece. Once you're at that onset of acceleration, you're into tarp 3 and probably heading towards a collapse. And that's the safety controls that are coming in. Okay. And keep in mind, you could be in tarp 3 for a very short period of time. Once you hit onset of acceleration, it can really progress. So tarp 2 could be months, tarp 3 could be hours. So do keep that in mind. All right, next slide. All right, something else that's super important, understanding and then communicating your risks. We've done a few of these recently. It's been quite valuable. And one way to try and do this is have a risk workshop where you can really just follow a simple SQRA, a semi-quantitative risk assessment like we've drawn out on the right here, where you might simply, it's sort of an event-tree kind of approach. What's the probability that you have an instability? Then what's the chance that it collapses? If it does that, what's the chance it reaches the working area? If it does that, what's the chance that you've got people there? And how vulnerable are they? And you can try and multiply that out. And then you'll evaluate your base case risk. Then you're going to put some controls in place to drive that risk lower and lower, and drive it to as low as reasonably practicable, which is this ALARP principle. Okay. Now, we don't have time to talk in great detail about ALARP. If you're in the tailings world, you'll probably know it very well. But it does provide a nice framework to do this risk workshop when you're looking at safety risk. And I will say the real value, I think, is in the discussions that are had in this workshop. Don't have too many people in there, but have the right people in there. And have people in there with different opinions, mining engineers, geotechs, perhaps a risk person from your corporate team. If everyone agrees in the first 10 minutes, that you don't want that. You want some heated discussions for sure. And it does provide a clear communication tool. You can plot your risks, your base case risk on an FN chart, for example, and then you can say, well, if we do X, Y, Z, we are driving our risk down into where we think is a tolerable range. We go to the next slide. Just a quick note on this ALARP, as low as reasonably practicable. Well, we're not balancing production and safety. I hear that quite a lot. Oh, we got to balance production and safety. That's not what we want. It's not what we're doing, and it's not what we want to do. We want to weigh the risk against the sacrifice in terms of money and time and trouble that is needed to avert it. And if the cost to do that is grossly disproportionate, then it may not be reasonably practical. And there's lots of reading you can do on this. But for example, if the business was to spend $5 million to stop 10 employees having bruised knees, that would be grossly disproportionate. But if you're going to spend $5 million to stop an explosion that could kill 150 people, that would be proportionate. Okay. If we think in a surface mining environment, maybe you've got a moving wall that's reasonably well managed, and you're looking at other controls. You could perhaps reduce exposure, queue trucks out of the way, but it would be grossly disproportionate to try and cable bolt and support the entire slope. Okay, so that's a little intro into the ALARP concept, and this, to prove it, that sits with the duty holder. It does not sit with the regulator, and you've got to do it ahead of time. So just go on to the next one, and look, a few final comments here. I had a conversation with a site recently, and they're saying, okay, well, who gives the approval? Who says, okay, we are going to do this? We're gonna progress mining below a moving wall. I don't think it sits with the geotech engineer. I'd like to hear Pat talk about this as well. It is a GM and above decision. If you don't have a RASI, I suggest you write one. That's responsible, accountable, consult, inform. Yes, the geotech engineer will steer, certainly, but the decision does not sit with the geotech engineer. It will sit with the general manager, maybe above. And look, the best managers, they're not going to know all the details, but they ask the best questions. Yeah, the best managers ask the best questions. And if your GM's not asking the right questions, then I'd raise it another level. Something else that comes up is, oh, can't we just let it fall down? Well, that's okay. But again, have we thought about all these things? So the image that you're looking at is this cost risk piece. And we're not going to go into all this, but it's in the paper. The general premise of it is to say, okay, what do we do? If we're not going to do anything, what's the chance that this slope collapses? Then is our safety risk managed to ALARP to as low as reasonably practical? Yes, okay. Let's look at the economic consequences of this, and then look at the probability of a collapse and no collapse. And then you have a cost risk. You've got a dollar value, and you're multiplying that by the likelihood. So yes, you can just allow it to fail, but we have to manage our safety, and we need to make sure we or the business are accepting of any consequences to do that. But yeah, you can certainly find yourself in that situation. You're trying to manage it operationally, and you're evacuating, you're in and you're out, and everyone's getting frustrated. And I will say that operations teams are very good at moving dirt. If a slope's falling down and they know what the problem is, they can move dirt. Everyone can rally together, and it's amazing what can happen. But are the corporate teams and the investors in favor of that? That's what needs to be presented, and that's the cost risk approach. And then lastly, make a decision. Just, don't, at some point, the team, the business are going to have to make a decision. Won't please everybody. That there's going to be a communication piece and an education piece to the workforce, but make a decision. take a view. So I'll finish there, and yeah, love to hear from everyone else.
All right. Thank you so much, Greg. For anyone who joined us late to this webinar, Greg has been talking about a new document that is available for download through the Large Open Pit Project website. I'm going to ask the GCE team to again post it into the webinar chat in case you missed that. But Greg has worked through the support of the LOP and BGC engineering to put together a document that overviews observational mining and managing moving pit walls. So he gave us a great overview today on that document, and now we're going to switch over to a panel discussion, but we'll also accept questions for Greg from you, the participants, as well as questions that follow up to our panel discussion. So first, before we go into the panel, Greg, I do see there is a question in the chat for you from Marco. Hello, Marco. So I will read that out. Let me see if it's in our slides. It is. Let me pull it up. So this is from Marco. So I'll just read this out. It's a little bit long, but I will read it. In this framework, the process starts with early detection, which already means movement has initiated. So without a strong geological understanding up front and without translating that into a performance-based execution plan anchored in instrumentation, how do we avoid operating in reaction mode?
Yeah.
So maybe hit that one first because there's three questions.
Yeah, no, it's a good question. And I think it's about, to me, it's making sure that given the technologies that we have available, you have those. There's no excuse in my mind to not have, to be looking at INSAR data, not to have prisms on the slope, GPSs, and at least one radar. I think I do think that's sort of shifting towards standard practice and making sure we are looking at that. You're trying to, and you're looking at those long-term trends, and you're just seeing that initial deformation, so you can do something about it. John Lupo wrote a nice paper that you guys should read. It was several years ago now, where he tried to look at that early detection stage, the different trends in onset of deformation, try and work out what the slope would do, whether it would collapse or not. I think that's right now the best we can be.
I think you just made an important point, Greg, and confirm me if this is kind of what you hinted at, that if a mine doesn't have real-time monitoring data, then all these things you've talked about, you cannot effectively manage a moving slope.
That's right.
And that might be what Marco's hinting at too there, I can't tell.
That's right. I think if you were to look at, if you did a risk workshop and you said, what's the likelihood, how effective is our TARP, and you don't have real-time monitoring, yeah, we are not carrying on until there's a good monitoring system in place. But you're right, we don't want to be doing it after the fact. I do think that base level monitoring, that early detection piece, should be standard. Certainly as your pit's getting bigger.
Perhaps there's a deeper seated underlying point there with that first line item, and that is around the risk that Greg talked to on the last slide. And when you take a project from PFS or FS into execution, there's still a fair amount of uncertainty in that geologic model, in that geotechnical model, in the structural model that supports that design. So the intent of understanding the risk is, you have to understand what your failure mechanisms likely are going to be based on what you know as of that date, and characterize that uncertainty and develop a plan around that. I mean, you're not going to know everything. So you may be in that first cutback operating in a bit of reaction mode until you get more exposure of that slope and a better understanding of the geology and the geotechnical criteria that support a design.
I was going to add a similar point, like the observational mining process actually starts with having an understanding of the potential instability mechanisms and how those would appear in the monitoring data. And as Pat noted, you'll have some uncertainty initially, and the uncertainty will progressively decrease as you get more experience with the slope. But yeah, you need to be in a position to recognize the early signs of the instability and then respond to it rather than purely reactive.
Yeah, and an interesting thing too is that in my experience, it's much easier to collect that data before the mining takes place than after, especially if it's already an active mine where you already have, a cut face that you can map at. That once the failure is already activated and moving, you may not have any access to get drill rigs in. You may not have any good spots or any safe pads to put the drill rig anymore. Once the slope is deformed a lot, it might be harder to collect some of that structural data that we want. So for identifying the failure mechanism, for understanding the geology, for getting ourselves better positioned to manage a slope that's unexpectedly moving, it's definitely better to collect that data up front rather than try to scramble and do it retroactively.
Well, that's a good point, Scott. One of the key things that I find that we miss from time to time is the validation piece. So we design a slope, we think we know a fair amount about it, we start cutting it, and we expose things that surprise us. But oftentimes our staffing resources aren't adequate to fully validate what's being exposed relative to what that design is. And I think that goes to your point. I mean, as we expose benches, the geology team needs to be out there mapping those high walls, feeding that information to the geotechnical teams. The geotechnical team should be out there cell mapping, collecting data on rock mass rating, and validating that against what their assumptions were in the model. And that's the time to get that data, not 10 benches below when you didn't collect that information. And now you got to scramble to go back and get it using photogrammetry or some other method.
Yeah, and it's really important it's really important for that team to also understand the impacts of those changes, right? Like, what will that do with the assumptions and the designs, and where does that come into play? So putting some sort of consequence to that validation piece.
That sort of leads into, I think, the next question, Jill, as well, when we talk about.
Yes, and I just wanted to also welcome anyone who is a participant in the webinar to enter questions in the Q&A. Click on the button in Q&A and you can type in there. And you can go ahead and do that. We have about 20 minutes for our panel discussion today, so please feel free to enter questions. Yes, Greg, do you want to move on to the second part?
Yeah, the other panel members spoke about it. All this work you've got to do, yes, it is dependent on budget, capacity, and experienced people, and it is hard because the big operations might have all that, but I would say most operations are stretched lean. That it's a shortage in the industry and so on. But maybe by looking at the risk, that can highlight to upper management that there is a shortage of either OPEX budget, or maybe our headcount is not good enough, and we do need increased capacity. And you could say, well, if we had that, here's where the risk would be, and that can be a nice case to make to increase your budget, get the people you need.
Yeah, that's a real key here, Greg. And going back to your last slide, that first bullet point about who's making that decision about whether or not to proceed. That most operations, or at least those that I've been working with, have a delegation of authority. So that delegation of authority is structured according to the risk, whether it be a safety risk or an economic one or a CSR related risk. And typically that decision doesn't land with the geotech engineer. It shouldn't land with the geotech engineer. They typically land at the lowest level with the operations manager. And subsequent to that, then the next decision maker would be the general manager. And it goes up the chain of command or the leadership chain until, or as a function rather of the risk. And those are our roles as geotechs is to educate and inform those leaders so that they can make that informed decision. And that's a critical aspect of our role. We shouldn't be making those decisions.
Yeah.
Would anyone else on the panel like to comment on either the first or second parts of Marco's question? We do have more coming into the chat.
Yeah, I think with the last question there, I mean, if you're running lean and you don't have effective monitoring or experienced engineers on site, I mean, and a lot of times in that situation, if the slope starts moving, you just have to take a large step out, which usually results in losing a lot of ore. You don't really have any other choice than that if you can't actively manage the slope. But I've definitely seen in my career a couple instances where that's happened at mines. This is probably 10 or 15 years ago. So kind of when radars were first coming onto the scene at most mine sites, that was the impetus to then purchase the radar. Because, the geotechs could say, hey, here's our analysis. If we don't have any more information, we might have to take, 100-meter step out or something to get away from this failure. But if we spend, X dollars on this radar, we can potentially recover part of the step out. And then you can, like Greg was talking about, do the cost benefit analysis really easily to show here's the cost of implementing this solution. And then here's the benefit in the reduced step out width and the ore that's recovered from that. And we can still operate safely and keep the miners safe. So when we're in that situation, that can be the impetus to do that cost benefit and then acquire the monitoring that's needed to manage it properly.
All right. Thank you very much, Marco, for your great questions. We do have a couple more that are coming in from the chat, and I would like to prioritize the questions that are from our participants today. So I'm going to pull up a second question. For our panel. And this came in from Dinella. Are you still able to mine a pit design safely if live monitoring, for example, radars, if subsurface instrumentation, TDRs, inclinometers, etc., has already shown shearing?
I would say it depends. But yes, in some cases, if you understand your mechanism and what are the consequences of a potential of a collapse? You have to accept that no matter what you do, if you mine below a moving board, you are increasing the likelihood that it may collapse. And if you're going to do that, there needs to be an acceptance by the business that everyone's okay with that, or the business is okay with that. And you will have to try and come up with it'll be very difficult to come up with a likelihood of it happening, but you're going to have to try and look at the amount of progressive, regressive cycles that you've had. But yes, it can be done. It has been done by a lot of operations. And make sure the rates are manageable. Make sure you're not mining ore that is moving too quickly, so that if it does progress to a collapse, you've got enough time to react.
I think as Greg noted, it must be underpinned by a understanding of the instability mechanism. And with that, combined with best available technology for monitoring and leading practices for interpreting the data, you can manage the safety risk to a tolerable level. And then you're left with the residual production risk, which can be addressed and accepted or not by the business. So, yeah, having it as the question lists, if your live monitoring with radars shows displacement that's corroborated by subsurface instrumentation, you can still proceed if you've got a sufficient understanding of the situation, the uncertainty, and the associated risk.
A good example of that is that pit behind me. That part of that pit wall moved several tens of meters over the course of the last phase. And it was because we had multiple redundant monitoring systems in place, both surface and subsurface. And we had reduced the uncertainty in the geologic and geotechnical model over the course of several years and several phases to help us have the confidence in being able to mine that slope. And in addition to a numerical model, it was very well calibrated. So it can be done, but you got to have a lot of things in place to be successful.
Pat, presumably you have to go and say to, GMs, corporate level people, this could collapse. Yes, we're going to do it, but there's still a chance it could collapse.
Oh, sure. I mean, it all, again, it comes down to the uncertainty in your geologic and geotechnical models and your ability to react in a timely manner with the monitoring tools you have at your hand. But again, it's from our perspective, it's all about informing and educating the leadership, giving them, as Greg said earlier, the opportunity to ask some of those difficult, pointed questions so that they can have some level of confidence on what they may or may not choose to sign off on.
And I think the other important part of this question too is to have an effective TARP that's implemented and has sign off from both ops and management and dispatch. And obviously that TARP would then need to be updated on a regular basis with the monitoring data in case we learn more about the failure as it moves. The failure mechanism could change. The displacement rates could change as we mine deeper and daylight more benches. But, to answer this question, also need an effective TARP to do something like this.
That's a good point, Scott. And it also needs to be quite flexible as well, like the mine planners and mine planning and your TARP, you're starting not knowing too much. And as things progress over 6 months, 12 months, 18 months, you're learning so much more, and updating that TARP accordingly is really important too.
All right. Thank you, panel. And thank you, Janella, for the question. I will move on to another question that is from Michael, asking the panel, do you have any tips on presenting or conveying this method to operators like drillers, truck drivers, etc., who are expected to work below these displacing slopes? Often they're hesitant even when there is good real-time monitoring in place, especially at smaller operations that don't deal with displacements as often.
Yeah, that's a good question.
Yeah, it is a very good question. I mean, from my experience, it's having that one-on-one, that communication with operators and going to the lineup meetings and just putting the information that out there and being transparent with them and talking to them and answering their questions. And over time, you really build their trust, looking at that data with them, maybe on a weekly basis or whatnot. But we've had similar experience with this. And over 6 months to 12 months, we've really gained a lot of their trust, and they gained a lot of understanding on how the radar worked and how we use the radar, and working with mine ops that way. So it's a lot of communication. Sometimes you're prepping a couple slides for them at the lineup meeting, but it's just putting that time and effort to get them. They don't need to be experts, but they want to know that you're expert, or that you know what you know and the things that you don't know, right? So I think communicating with them is a key thing, and not being not being afraid of presenting that to them.
I really like what you noted about being transparent. I think you described it as being transparent about the level of uncertainty as well. And just presenting it, there's no way around it, presenting it in plain language, what the situation is, the level of understanding of the instability mechanism, what it's shown, what you're looking for. And then, just making it clear that there's a well thought out plan to manage the risk, including evacuation triggers. But that one-on-one or small group time is the most effective in my experience.
Yeah, and they have a role to play as well. They need to know about this, because when they are part of the TARP, they will have however you've written your TARP, they're going to have a responsibility that will be part of an evacuation plan. Or it might go further than that, depending on your controls. That might be limited. It might, the exposure piece, you might only allow critical personnel into the working area. But they have a role to play as well in this.
Yeah, one of the key things we found is it's successful at our operations here is educating the operators, the boots on the ground. To Greg's point, you have many, many, many pairs of eyes through that operations team that see things that you're not likely to see. They may be your first line of defense. So if you educate them properly on what to look for and give them the confidence to reach out to you through their supervisor or some kind of an on-call phone number, then you've just expanded your monitoring repertoire and can help get ahead of some of these movements as they're developing.
Yeah, and another group that's really important to get on board and have involved and understand everything is the dispatch group. Just because if there is a certain area that's high risk or semi-limited closure because of the tarp, often you'll have to call dispatch before you enter those areas. And so if the radar starts moving, dispatch should see that, the geotech team should see that, and then very easily between communications between those two groups should know essentially who's in that area and who might need to be evacuated in the event of a tarp alarm.
Jill, are you supposed to be are you talking?
I was talking, sorry. I'm always telling everyone else to unmute, and then I
Everyone else
forgot.
has been, well, the rest of the panel are too polite. I think that's
Oh, yeah. Thank you. Thank you for letting me know, Greg. So thank you for all the great questions that have been coming in. There are a number that we won't be able to get to just based on the duration of the webinar, which we have just a little over 5 minutes left. I have seen a couple of questions come in that I'll maybe group into just a general question on how is this method being accepted by mine regulators? Do you think that it will be involved in any type of governance? How is this being accepted in industry and applied? How widespread?
Yeah, in my experience, when we've had, say, MSHUR come to site, the reality is we've known more than they will ever, or more experienced, certainly at the geotech aspect of things. But they are looking for that you have controls in place and so on. How will this? It's really, with the new LOP book is being written at the moment, and I'm sure various people on the panel are involved in it, and there's lots of discussion as to how the verbiage in there will be taken, especially when we talk about performance-based design and how that will be sort of fed into regulation. I don't fully know where it will go, to be honest. So I'd be interested to hear what the rest of you are thinking.
I mean, I'd say that pit slopes have been moving as long as, humans have been mining pit slopes. So it's, if there was a new regulation about moving pit slopes or, a new way to regulate it, certainly nothing's different than it was 20 or 30 years ago before some of these techniques came out. So if anything, things are a lot better and a lot safer now because we have the tools to actually to monitor in real time what's going on with inverse velocity. We have tools to actually do predictions. With numerical models, we have better tools to analyze what's actually happening beneath the surface, what the actual failure mechanism is. So I think we can actually do it a lot safer than we could 20 years ago, even though we can sometimes be more aggressive with the mine design and, get more ore recovery while also mining safer at the same time.
Yeah. And I suppose you're not going to have, there's been discussion about will an engineer of record for pits, and I don't think that's, yes, we can have it for the tailings dam, but we're not going to have an engineer of record for pits. There's just too much changing on a day-to-day basis for anyone to be an EOR.
Yeah, and I agree with that, Greg. We've been asked a few times about that, and it's hard because if you're the engineer of record, you'd have to sign off on any change at all in the mine plan.
Yeah, that's right.
But it's like all the time, you might assay this part of the bench that originally was waste and now it's ore. So the short-term team wants to change it to recover that ore, that's great. But if the engineer record had to sign off every time that happened, it'd be too much, it'd be too crazy.
Yeah. Designer of record, maybe. But,
yeah, exactly.
Yeah, that was one question here that came in about comparing the trends to the tailings geotechnical governance that has really taken off.
Yeah. It's something that's definitely getting thought about with the LOP. But again, your pit is changing on such a day-to-day basis. It will be interesting how the new LOP book, the slope design guidelines book that's due for publication, I want to say next year, it's guidelines, it's not an SOP. How will that be interpreted by people in the industry? Even if we think about the current Reed and Stacey book, the factor of safety tables in there, they were put in there as a suggestion, and the numbers were sort of smoke-filled room type stuff, and it's become those tables of suggested design acceptance criteria have been put in. They're all in almost every pit design report you can think of. So I think we do probably have to be quite careful as to where this goes.
The key is to continue improving and learning. We're reaching the end of our webinar, but I wanted to just give the panel a chance to leave us with one closing thought based on this question here. So I'll ask each of you if you would like to just briefly comment on, based on everything we've talked about today. We've had some questions about what challenges, what gaps are present for the geotechnical engineer in their decision making. So if you had to choose one improvement that the industry needs most, or just the first one that comes to mind, what would it be? For example, better data, interpretation, decision-making framework, alignment between different areas of the operations. So just a final thought, and I will invite the panel to briefly comment on this before we close the webinar.
I guess I'll go first.
Go ahead, Scott. Yeah, thanks.
I guess for me, when I go out to mines right now, the biggest challenge now is that there's so much data and so much of it is in real time, right? That there's just reams and reams of data coming in, all sorts of different sources, all sorts of different providers. And it's starting to become a real challenge to deal with so much data on a real-time daily basis and do it quickly and effectively. And I think it's a challenge across the industry right now. So I know a lot of different mining companies, different providers are working hard to improve, those platforms that can summarize all that data and make it usable and make it applicable. But I think that's a big challenge that hopefully within the next 3-4 years, we might see some solutions and some improvements on to let us better use all this data this high quality data that we're collecting.
Good. How about you,
I would
Karyn?
agree. Yeah, I guess I have two answers to this question. One, it's like leaning on something Pat said, but I definitely think an understanding of risk, like the assumptions that go into these design reports and what those mean, and when the assumptions are not validated, or if you're seeing different things, what the impacts are of that. So just a general understanding of the gaps and recommendations in these reports from the team on site. And then another thing too, I find is like in operations, a better understanding of what the mining engineers are dealing with and the geotechnical engineers are dealing with. And so having a better exchange of thought and communication from the different technical services teams, I think is really important, and those teams collaborating. So seeing an improvement there, I think would be really great for the industry.
And Greg, Andrew, or Pat?
I think in the next while, the industry will benefit from more experience and guidance on communicating uncertainty and also reconciling that with the idea of managing risks to as low as reasonably practicable. I think the LOP guidance note really helps with that, but yeah, I'm just looking forward to building up more experience in that and test driving it a bit further.
and I agree with everything that's been said. Actually, it's maybe one. I think Scott's one is very good. Something I've noticed is executive committee members, board members at the top of the food chain, sadly, are not mining engineers anymore. Maybe you're lucky to have one or two, but they are finance people. I always think that's a shame because they don't really understand what's going on. Is it going to ever change? Probably not, but it would be nice.
And Pat, would you like to have the final word today?
Sure. I think from my perspective, I think getting back to basics is critical here. Just to Scott's point about the data overload, I think that we're missing the point about having solid geologic and geotechnical models that feed the design. Just from a couple of recent experiences here within our business, we've had issues develop because those models had such high uncertainty and questions weren't being asked, challenges weren't being thrown to various members about the uncertainty in the model and what does that mean relative to my design acceptance criteria. You're designing a slope for DAC of 1.3, let's say, but that's inconsistent with the fact that the slope's moving. Obviously, there's a gap there. So I think really getting back to basics and working collectively across disciplines, geology, geotech, hydro, operations is critical.
All right. Thank you so much, Pat. You have some agreements coming in the chat. We have run a few minutes over. I appreciate that you stayed to discuss this final question. I want to thank our panelists very, very much for their time. We really appreciate you. And I'm sure we could spend much more time talking about this. And hopefully you'll be back again for another webinar on another geotechnical topic. Thank you to Greg. If you didn't get the information to download Greg's paper, you can send an email to us there at gcecourses@arizona.edu. We can point you in the right direction. And we hope to see you at our next monthly webinar. Thank you so much to Greg. Thank you so much, Karyn, Scott, Andrew, and Pat. And thank you to our participants. We will see you next time.
Cool.
Thank you, everyone.
Thanks
all.
everybody.
Thank you.